All right, another proof here. Okay, looking at this statement that I'm trying to prove, I see the left side looks a little more complicated than the right, but when I look at the left side, I'm not completely clear what to do right away. So I'm going to start on the right side. And one thing I want to point out is that this is tangent of alpha plus tangent of beta. So those are not the same. And so this is why you always have to write the angles that you're talking about. So I'm going to go ahead and start on the right side. So I'll rewrite it. All right, kind of our typical strategy. Let's change everything to sine and cosine, especially since the left side's all in sine and cosine. So this is sine alpha over cosine alpha plus sine beta over cosine beta, and then blah, 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 minus sine alpha, cosine alpha, sine beta, cosine beta. All right. So I look at that top and bottom and I say, okay, if we multiply the top by cosine alpha, cosine beta, and the bottom by cosine alpha, cosine beta, that'll clear out the fractions. So let's do that. All right, so now we just have to be careful. So now we're distributing this into this, okay? I can see that the cosine alphas cancel out, and I'm left with sine alpha, cosine beta. All right, sine alpha, cosine beta. That's the first term. Now when I distribute this into here, I notice that the cosine betas cancel out, and I'm left with cosine alpha, sine beta. That's really good because that's exactly what I want. Okay, and if I look at the bottom, distribute this times 1, that's easy. That's cosine alpha, cosine beta. Plus, when I distribute this in, these cancel, and I'm up with sine alpha, and that's a minus, by the way, sine beta. Wow, that's exactly what I wanted to prove. So we are finished. Boom.